So today we're going to start chapter 1, section 1. And today what we're doing is laying the foundation of everything we're going to be doing all year long. Now, what's important is whatever we're learning now in chapter 1 doesn't go away. We're going to be using this over and over again in every single chapter. So the first thing we're going to do is define what a point is. And a point is a single dot. It is going to be the simplest figure in geometry. It can be named by a capital letter. And all geometric figures that we're going to talk about this year consist of or made up of points. So in the picture here, I have 2 points that are labeled here. So when you see the capital letter, you're also going to see a little dot next to it, indicating that it is a point. Now, a point has no dimension and no size. Now, for this third bullet point, that all geometric figures consist of points, let's say I draw 3 points on my paper and I connect them. Once I connect this, it actually makes a geometric figure, and that geometric figure that I just drew is a triangle. I can also draw, for example, a square. If I were to have put 4 points on my paper, I would just need to make sure that all sides were the same length and it had 4 right angles. But that's coming up in the quadrilateral chapter. Just know that all geometric figures consist of points. So a line is a geometric figure consisting of at least 2 points, and it extends in 2 directions without end. So a line goes forever. You can name it by 2 points that are on that line or a single lowercase letter. Just know that through any 2 points, there is exactly 1 line. Now, notice that in this figure here, on the ends of the picture, there's little arrows indicating that this is a line and it extends without end. Now, this little thing that looks like a 1, this is actually a lowercase letter L, and it's in italics. So we can name this picture of this line by either typing out the letters L-I-N-E and spelling the word line, and then labeling 2 points that are on it. Or we can also name the line by putting the 2 points on the line and then drawing a picture of a line on top of the capital letters. Or by naming it with the lowercase italicized letter. But what's important is that you include the word line in front of it. So for example, let's do another one. Now also a line has 1 dimension. Now, the order when you name a line with the capital letters, this same picture that's here, I could also name the line BA. The order of the letters doesn't matter when naming a line. Or I could have also just typed the word line and then put the capital letters. So you either need to put the word in front or draw the picture of a line on top. So just to give you another example, let's say I put points X, Y, and Z on here. And let's say I call this line lowercase letter D. So I could either name it with the lowercase letter, but I have to spell the word line in front. Or I could pick any 2 points. You're not going to name it with 3. Either write the word line and then 2 of the points, or put the 2 points with the picture of the line on top. All of these would be acceptable names for that picture. You could have also called it YZ, but make sure you include the picture of the line on top or the word in front. Back when we were online because of COVID, when my students were taking tests on Canvas and on the computer, a lot of them weren't familiar with the equation editor, and they didn't know how to put these symbols on top of their letters, so they would always resort to the naming convention of actually typing out the word, L-I-N-E, and then typing the 2 points. However, because we're now back in person and you're actually doing this on paper, you can choose which naming convention you wish to choose. So this other line that I just drew, there are a bunch of different ways you can name this. And again, the order of the letters doesn't matter. Just pick any 2 points. Now you can't do this. You can't do D with this. That's not acceptable. If you're going to use that shortcut of drawing the picture of the line, it has to be with 2 capital letters. If you use the lowercase, you have to just type in the word line. The next definition is the definition of a plane. A geometric plane could be a good example of a real life thing, would be a floor, the wall, the tabletop. However, what you need to imagine is this floor, this tabletop, or this wall extends without ending. It goes on forever, just like a line, and it has no thickness. So a plane goes forever. It's kind of hard to draw that. So down at the bottom, that red parallelogram, generally a plane will be drawn as a quadrilateral, but just know that those edges of that plane go on forever. So although it has no edges, it's going to be pictured like a quadrilateral. You can either name it with a single capital letter, as long as that capital letter doesn't have a dot next to it, or 3 or more points that are in the plane. So for example, notice the capital M there doesn't have a point next to it, but let's say I add in the letters A, B, and C. In addition to naming this plane M, I could also name it plane ABC. So you're either going to name it with a single letter that's not a point, or with 3 non-collinear points. We're going to see the definition of collinear in a minute. Now, sometimes they'll name a plane with 4 points, but all you need are at least 3. A plane has 2 dimensions. Three more definitions. First one is the definition of space. And space is just the set of all points. The definition of collinear are just points that are all on one line. So if I were to draw a line and add some points to it, I could make the statement that points A, B, and C are collinear, because they're all on the same line. If I were to draw in a 4th point and put it up above the line, say I put point D up top there, then I could make the statement that points A, B, and C, and D are non-collinear, which means they're not on the same line. So I could state that A, and you don't have to name all 4, you could just name whichever ones are not on the same line, are non-collinear, because point D is not on that line with A, B, and C. Coplanar, points that are on the same plane. So again, remember you're going to see a plane drawn as some type of quadrilateral. And let me add some points to it. So I could state that points X, Y, and Z, I could state are coplanar, because they're all within my picture, which is representing a plane. If I were to add in a 4th point, let's say I call it W, Now I could state that X, Y, Z, and W would be non-coplanar because W is not in that plane with those other three. Next, we're going to talk about segments. So here, a segment is, or segment AB in this picture, is going to have endpoints. It's not going to go forever. So you could have a line AB. However, when they refer to a segment, they're only talking about part of it, where it starts and stops. So notice that when I refer to a segment, it doesn't have arrows on the ends. It has endpoints. Just like the line, you could also name this BA. You could do it in reverse. You could also write the word segment and put the 2 points that are the endpoints. Segment is the only one that doesn't need a picture on top of the capital letters. So if you ever just see AB with no picture or no word in front, know that they're talking about a segment. If you were expected to name a line, you would have to include the picture or the word line on front. So the order here doesn't matter when you're naming a segment. All right, rays. Now, you can name a ray by just writing the word ray and then the 2 points, or you can write the capital letters, the 2 points, with a picture of a ray on top. However, this time, the order matters. So the first letter you see is the starting point, and then it's going to continue on unending in the direction of the second letter. So for example, ray AB is this picture here. It starts at A, and then it continues in the direction of B forever. Now, when I'm talking about ray BA, it starts at B, and it goes in the direction of A. You never want to name this with the arrow pointing to the left. So for example, let's say it was this way, a B here, and then an A. You would still name it like this. Or even if it were like it showed in the picture, B here, and then the A, it's still named this way. You don't change the direction of the arrow when you name it. Order matters here. So where the closed circle is, that's your first letter. And then the letter that's closer to the arrow is the second letter. So order matters here when naming rays. Opposite rays are going to be, they're going to share an endpoint, but they're going to point in opposite directions. So for example, on this line AB, I can state that ray CA here, which starts at C, and it goes in the direction of A, is that ray, and then ray CB starts at C and goes in the direction of B. So they both start here at C, but they point one to the left, one to the right. They point in opposite directions. But they always have the first letter in common, the starting point. So notice the C is the first letter, so this is your common endpoint. So intersection, or the word intersect, means to meet or cut through. So for those of you maybe are starting to learn to drive, or even when you drive in the car with your parents, wherever two roads meet, like at a stoplight or a four-way stop, that is called an intersection. So it's where the two roads meet, and the light or the four-way stop is like the point of that's in common to both roads. So the intersection of two figures is going to be the set of 2 points, or set of points that are in both figures. So for example, let's say my 2 figures are 2 lines. So I have a line going this way and a line going this way. Their intersection is going to be the point that's in common. So that black point is on the red line and it's on the blue line, and that would be the point that is in common to both, and that is the point of intersection. So 2 lines always intersect at a point. So 2 lines intersect at a point. The other picture that's already drawn for you, that's a picture of 2 intersecting planes. Now, sometimes when you're given these figures and they're like 3-dimensional or 2-dimensional, sometimes you're going to see dashed lines or dotted lines. That's just indicating maybe something that would be on the back side that you can't see. So any parts that might be hidden from view. Now, what you have to remember is that a plane goes forever. So the intersection of 2 planes is always going to be a line. It will never be a line segment because planes go forever. So 2 planes intersect at a line or in a line. And this picture, the line of intersection is this line right here. This is where the 2 planes intersect. It will never be a line segment because line segments end and both planes and lines go forever. So example 1, now it's just asking us to state whether it's true or false. Notice that there's no diagrams given for any of these questions. Generally, when you get a question where there's no picture provided, it makes the question a little more challenging. What you're going to see on the next slide is still true-false questions, but you're answering true-false questions based on a diagram. And you're going to see that those questions are a little bit easier. Now, one other type of question that we like to give are sometimes, always, or never questions. And what those types of questions are, they're sort of like true-false on steroids. They're a little bit more challenging than just a yes or no, or true or false. So you're going to see that coming up in some of your homework assignments. And sometimes they'll appear on some tests and quizzes as well. So let's go ahead and let's try to see if we know the answers to these. Number 1, line PF ends at point P. True or false? False. Beautiful. Does a line end? No. So that's why it's false. A line never ends, so it can't end at point P. Now the next one's a little tricky because if I were to just draw a point here and label it point S and then try to start drawing lines through it, you may start to think, well, there's only a limited number of lines I can draw, but you got to remember that not only can you draw it flat on your paper, it could go through up and down, side to side, and it can go through every little angle possible. So this is actually a true statement. There are an infinite number of lines that will go through that point. Number 3, a plane has no thickness. True or false? Beautiful. It's right from the slides. So this is true. A plane has no thickness. Collinear points are coplanar. By definition, a plane is supposed to be 3 non-collinear points, but this is actually true some of the time. So I'm going to say it's true because you could draw some collinear points and surround a plane. However, technically by definition, a plane is defined as 3 non-collinear points, but this case is sometimes true. So in this case, since we're not doing sometimes or always or never, we're just going to say it's true. How about planes have edges? False. Good. Remember, it goes forever. Two planes intersect at a line segment. Beautiful. It always intersects at a line, not a line segment. So the way it's written is false. It has to be just a line. Two intersecting lines meet at exactly 1 point. This one is true. So there's that. X marks the spot. This one is true. Points have no size. True. Good. Now, the next one, the word denotes means is, can you name a line with either the word L-I-N-E and two letters, or can you name it as YX or XY? Now, my font shifted a little. This picture should be right on top of the letters. So this is actually a true statement. So you could either name it by writing the word L-I-N-E in 2 points, or put the picture on top. So this would look something like this, X and a Y. And remember, the order of the letters doesn't matter when naming a line or a line segment. All right, next example. This time we got a picture, and it makes it a little bit easier. To the picture, just to clarify which ones are points. So X is a point, A is a point, Y is a point, P is going to be a point. However, N and M are going to name the planes. So N is for this plane, and M is for this one. And then B is just that lowercase letter, it's the line. So P, point P, is in plane M. True or false? False. Beautiful. It's not in that blue section, so this one is false. How about line B is in M? True. How about line YX contains point P? False. Because here is line YX and P is not on it. All right, what about A is on line B? Oh, I skipped one. M contains line YX. True. Good. And now A is on line B. This should have line in front. True. Same thing here. This should have line in front. All right, next one. A and P, so points A and P, are in plane M. This one was false. And then the last one, plane N contains P. True. Beautiful. Okay, so again, a lot of times when a picture is given to you, it does make it a little bit easier. So again, if a picture is not provided, draw yourself a picture. I'm not going to grade you on your artistic ability. Whenever you draw something on a test or a quiz or in the homework, it will be for your use only. And that is the end of section 1.